Hello, and thank you for joining us today for BioTek's webinar event. My name is Lindsay, and I will be the moderator for today's webinar. The audio for today's webinar will be coming from your computer speakers, so please be sure they are turned on and the volume is up. To ask a question, please use the chat feature. It is located in the bottom left-hand corner of your screen. You can send in your questions at any time. Our speakers will address the questions during the Q&A session at the conclusion of the event. If we do not get to your question, we will do our best to respond by email. Today's webinar will be presented by Wendy Goodrich, Application Scientist, and Elaine Abweg, Product Manager Specialist. We'd like to thank them for joining us today. With that, I'll turn things over to Wendy to get us started.
Thank you, Lindsay. Dogs, cats, birds, fish, bunnies, and guinea pigs, young people, old people, all people love their pets. And one of the first visits to the vet for many new pet owners is to receive a vaccination schedule. There are core and non-core vaccines available to be given to pets, including those for rabies and Bordetella, respectively. But our pets aren't the only animals on vaccination schedules in the U.S. For example, large animal agricultural livestock are vaccinated as part of nationwide managed herd programs starting as young as pre-weaning. There exist conventional live and killed products, genetically modified live vaccines, vaccines with Bioassays, or those developed along with tests that can distinguish vaccinated from non-vaccinated animals, and DNA and RNA vaccines. There are also many licensed diagnostic products, for example, test kits that are used to determine animal or herd disease status. There are antibody products for treatment or prevention of disease, immunostimulants, and immunomodulators. There are hundreds of animal vaccines and other biologics in production, millions of doses in distribution and banked and reserved, but all biologics for use in animal health within the United States must be approved for release by the Center for Veterinary Biologics under the umbrella of the United States Department of Agriculture Animal and Plant Health Inspection Services. The mission of the Center for Veterinary Biologics lies in regulating veterinary products of biological origin as part of enforcement of the Virus Serum Toxin Act. This includes product inspections, wherein test results of every batch of veterinary biologic are submitted by the manufacturer for review. Results are compared with check testing conducted by the CVB's Policy Evaluation and Licensing Unit, and each batch is approved or rejected by CVBIC for marketing. One metric used for results comparison to standardized reference biologics is the estimated relative potency value of vaccine test serials. Until December 2013, when it was discontinued, the CVB offered a software program called RELPOT, a proprietary tool for estimating relative potency of firm test serials intended for release within the United States. It was offered free upon submission of a request form. RELPOT Legacy and any new firms are now required to transition to or adopt a commercial software alternative to RELPOT before January 1, 2016. By this date, firms should develop proposals for transitioning each approved assay using RELPOT software to other software and submit such proposals to CVB Policy Evaluation and Licensing for consultation and approval. To assist in this as a replacement to RELPOT, CVB published a Guidance and Requirements document, CVB SOP 0102.01, on March 14, 2014. This document outlines procedures for validating and calculating the estimated relative potency value required for veterinary biologics release. Any commercial software package can be used as long as it meets the criteria defined in this standard operating procedure. In consultation with CVB, BioTek responded to the new SOP by creating 6 sample files compatible with our Gen 5 software that have all necessary validation and calculation requirements of the SOP pre-programmed. A reference and link to the Gen 5 sample file and TechNote location on our website was added to the CVB Reviewer's Manual, Chapter 4.6.2, using software to estimate relative potency in September of this year. Other important guidance documents are also available from the CVB website, in particular Veterinary Services Memorandum 800.112 dated August 29, 2011, that contains guidelines for validation of in vitro potency assays. The CVB SOP document describes methods used by CVB laboratories for estimating relative potency in enzymes, immunoassays during testing activities such as the serial release testing of veterinary vaccines. Relative potency immunoassays of veterinary biologics typically compare a test lot or serial to a reference standard. In sections 1.3, two methods are described by the SOP based on the concept of parallel line analysis between the reference and test serial. The first, a linear or partial linear data approach, and the other, a full dose response model using a 3-parameter logistics fit. Either of these models can be done using concentrations or dilutions of reference standards and test serials for plotting the x-axis data. All necessary constraints and criteria for arriving at a final valid estimated relative potency value using either of these methods, in addition to other criteria for verifying parallel line analysis results, are further described in detail in sections 4 and 5 of the SOP. The Gen 5 sample files contain all necessary calculations, curve fitting constraints, and validations required by these sections of the CVB document. Today, we're going to present some context for the content of the BioTek Gen 5 TechNote and sample files, followed by a walkthrough designed to highlight features of interest to end users when editing the sample files for their specific application. The Gen 5 sample files and a companion TechNote can be downloaded from our website, www.biotek.com. Once downloaded, the sample files can be customized according to any individual requirements using the TechNote as a guide. The TechNote contains 3 major components. It provides supplemental background information on the estimating relative potency algorithms, instructions for how to edit the sample files, including those parameters embedded into the files that should not be edited, and finally, a brief explanation of how to review and analyze results generated from a plate read. The chart here, as contained in the TechNote and on the website, gives details regarding the contents of the 6 sample files to aid an end user in selecting the appropriate one for their data analysis method. All sample files are populated with example data and contain validation formula, curve fitting, and constraint parameters defined for a reference curve and 1 test serial. Up to any number of test serials can be added to a sample file within the confines of a single 96-well microplate format. Assuming an end user has a version of Gen 5 greater than or equal to 2.01.14 installed on their computer, opening the corresponding sample file specific to your application from our website will bring you directly into Gen 5 with the selected file active. In the background section of the TechNote, there are some highlights that clarify parameters and constraints in the Gen 5 software as they relate to the language used in the CVB SOP document. Gen 5 uses parallel line analysis to calculate a proprietary rep metric, and the rep metric is then used to calculate the estimated relative potency as defined by CVB. Parallel line analysis is a feature within our curve analysis interface. The reference standard is used as the reference curve, and test serials are defined to evaluate relative potency in parallel to the reference curve using either the 4P fit or the linear curve fit methods. Parameters within the curve equations are used to validate parallelism and calculate the estimated relative potency value required by CVB. Those would be these parameters here in each equation. Both curve fit models for both concentration and dilution as accepted by CVB are offered in the Gen 5 sample files. The full dose response model may be fit using a 3-parameter logistic curve by constraining the lower asymptote of a Gen 5 4-parameter fit to 0. The A and D parameters in the Gen 5 4P fit equation represent the lower asymptote depending on whether the curve is competitive, that is, it descends left to right, or non-competitive, it ascends left to right. These constraints are already embedded into the sample file curve fit definitions and should not be edited. The CVB requires validation of both the upper asymptote and scale factor ratios between the reference and test serial curve fit results when using the dose response model. The Gen 5 parameter values used in the validation equations and their corresponding CVB SOP definitions are shown. Of note, the Gen 5 4-parameter fit algorithm always resolves the B parameter using the absolute value. That's shown here and here. That's the B value. So B is always positive in Gen 5, even in a competitive curve model that descends from left to right. B corresponds to the scale factor in the CVB SOP. When using a linear or partially linear model, the CVB SOP requires that parallelism be validated between the reference and test serial slope values. If the slope ratio falls within a predefined numeric range, it's considered valid. If it falls outside the range, it results in a no test. Within the Gen 5 linear curve fit equation, parameter A is designated as the slope. That's shown here and here. That corresponds to parameter M, referenced in the CVB SOP. For either curve fit model, the rep metric in Gen 5 is considered a curve parameter. This metric indicates the value of the relative potency coefficient defining the correlation of parallelism between the reference and test curves. Rep is used to calculate the RP estimate required by the CVB SOP. The RP estimate is calculating using a predefined transformation equation in the Gen 5 sample files, where RP estimate equals rep for tests using concentration on the x-axis, or RP estimate is the reciprocal of rep, or 1 divided by rep, when the x-axis is defined using dilutions. According to the CVB SOP, the estimated relative potency value is required to lie within a defined numeric range. This equation is also predefined within the sample files. Depending on the immunoassay protocol followed, there may be other requirements for blanking raw data or validating assay controls that aren't included in the Gen 5 sample files. These can be added at an end user's discretion. Although the sample files include all necessary constraints and equations for parallel line analysis, validating parallelism, and calculating and validating relative potency estimates, it is ultimately the firm's responsibility to ensure that all protocol components satisfy both the corresponding assay SOP, supplemental assay method, or other protocol, in addition to the requirements in the SOP 0102.01 for their test serial. Additional clarification on the meaning of the relative potency concept in several classes of assays commonly used to evaluate vaccines, refer to the article Interpretation and Estimation of Relative Potency in Vaccines, published in the Journal of Immunological Methods, available from the link at the bottom of this slide. Illustrated here is how representative results and curve parameter values appear within two different sample files. Both are resolved using a full dose response model based on data from a non-competitive binding immunoassay. But as shown by the x-axis label, one is calculated on concentration and the other using dilutions. The sample file on the left is an ascending concentration sample file. That is, the signal increases relative to concentration, so the higher the concentration, the higher the signal. And on the right is a descending dilutions sample file. The signal decreases relative to increased dilution, or the greater the dilution, the lower the concentration, and therefore the lower the signal. In addition to the inverse relationship of dilution to concentration for the same immunoassay method, principles of the lower asymptote constrained to 0, the positive B value in both cases, and the relationship of the Gen 5 rep metric to the CVB required estimated relative potency value are also shown. Worth mentioning, in the results drop-down menu, curve results can be seen for a test serial, the reference curve, or parallel line analysis between a test serial and the reference curve, as shown here. Although somewhat hard to see on this slide, right here, there is a parallel line in the curve name, indicating results generated from the parallel line analysis of test serial 1, in this case, to the reference curve, and that parallel line is right there. I know it's hard to see. Results are available for each test serial defined in the protocol. Since all sample files are populated with simulated data such as this, an end user can easily review example data prior to editing the file specific to their application. The parameters most commonly edited within a sample file will likely include the procedure, where the wavelengths used in the plate read step are defined, the plate layout, where additional test serials can be defined and dilutions and/or concentrations are edited, data reduction, where validation equations can be copied and edited for new test serials, or data in fields edited if dual wavelength or blanking are integrated, and the embedded custom report export, where data out variables may be added if different from the sample file defaults. Of note, embedded in the data reduction equations is some custom syntax that may be unfamiliar even to experienced Gen 5 end users. These are worth pointing out as described here. And except to copy, paste, and update the test serial numbers, the variables and formula syntax of equations within the sample files should not be edited. First, because numeric ranges for parallelism and estimated relative potency value validation can differ for the immunoassay target of interest, these were defined as runtime prompts within Gen 5. These variables are shown preceded by an exclamation point and will appear as prompts before a plate read, as shown on the right. An end user would type in the numbers at that time, and the software will use those numbers when validating the parallelism and estimated relative potency equations. Runtime prompts are defined within the protocol runtime prompts interface from the Gen 5 main menu. Another group of custom syntax values are those used to reference the numeric curve values of the curve parameters. Shown at the bottom of the screen is the formula for validating the ratio of the upper asymptote value of the test serial to the reference curve for an ascending full dose response model. Curve parameter D represents the upper asymptote in an ascending curve. The first and last tokens of the equation, min UA ratio and max UA ratio respectively, contain the leading exclamation point, indicating that these values are obtained from the user input value at runtime. Within these two, within the min and max range, parameter D, sorry about that, from the test serial curve is divided by parameter D of the reference curve. There needs to be one equation for each test serial within the sample file as indicated by the token TS curve TS1. So this number here is what someone would edit if they're adding an additional test serial to the curve. Subsequent test serials would be then referenced as TS1, TS2, TS3, etc. Highlighted in yellow, right here, is the syntax used to reference the Gen 5 rep metric calculated from the parallel line analysis of test serial n in the reference curve. An equation for this validation, not shown here, is also required for each test serial, editing n to each test serial number respectively. The parallel line in the middle of that token helps clarify the meaning of the variable and should look familiar as the curve name shown earlier. Now that I've provided some top-level context for the content of the Technokin sample files, Elaine will be working live from the BioTek website and Gen 5 software to present an in-depth tour of editing sample files. I'd also like to remind people that if you have questions throughout the presentation, to feel free and type them into the chat box, and we'll have time to answer them at the end of the webinar. We're going to give Elaine a minute here to bring up
Okay, thank you, Wendy. In this portion of the webinar, I will be covering the Estimating Relative Potency Techno by explaining how to edit a dose response sample file, and then go over the Gen 5 output for a linear sample experiment. The sample experiment files can be found on biotek.com under the Applications topic in the Sample Files tab. If we browse to the Gen 5 sample files for absorbance, you will find them here. Please note that all 6 sample files can be downloaded from this page, along with our tech note, which can be found using this link. For our exercise, we are going to use the file called rp_descending_dil.xpt, and as indicated in the tech note, you must first download and open the sample experiment file as we have done here. In order to customize the protocol for your particular assay, you must first save the protocol and open the protocol file for editing. Please note that I am using Gen 5 version 2.06, which is our latest release, but the sample files are compatible with Gen 5 versions 2.01 and higher. So in order to save this protocol from the sample experiment file, just go to File and go to Save Protocol As. And I'll just give it a name and go back to the Task Manager and open that protocol. That way it's ready for editing. And the protocol will consist of the procedure, plate layout, data reduction, and report-export builders. Any of these sections can be edited. For example, if we open the procedure, any of these steps can be added here, or the wavelengths can be changed. The next section that may be of interest is the plate layout. In the sample file, REF stands for reference curve, while TS is the prefix for test serials. TS1 is test serial 1, TS2 is test serial 2, and so on, while NPS stands for wells that are not part of the study as indicated in the CVB SOP. This particular file that we opened is for a descending dose-response curve with dilutions. You may wish to edit those dilutions while keeping the order. To do that, simply click on the left margin and open up the ref curve. And I'm going to change this to 1 to 2 dilutions by typing in 2, 4, 8, 16, 32, 64, and lastly 128. I'll hit OK, and what Gen 5 will do is automatically change the associated wells, as shown here. Now you must do the same for the test serial. Only this time, instead of entering each dilution manually, we're going to use this factor box as a shortcut. Since it's a factor of 2, I just type in 2, place my cursor in the top line, and use the down arrow to fill in the following line. And for this particular assay, you may even choose to add a second test serial 2. In order to do that, again, let's change the dilution. And then choose the wells that you want to insert your new test serial. The next section that you may wish to edit is a data reduction. You will see our defined reference curve, which is used as a reference curve for Gen 5's parallel line analysis. In the Curve Fit tab, we have indicated a 4PL curve fit, which is changed to a 3PL curve fit by constraining the lower asymptote, in this case, parameter D. We have constrained it to 0. It is important not to change this constraint, which may differ depending on the sample experiment type. The next curve defines the test serial curve, which will be evaluated for relative potency against the reference curve. The third step is for validating the upper asymptote ratio and the slope factor for each test serial. As mentioned earlier, the upper asymptote in a 3PL curve could either be parameter A or D, depending on the shape of the curve. The sample files will already have this pre-programmed, which is why it is important to use the chart in the tech note to help you choose the correct sample file. In this particular file, parameter A is the upper asymptote, while parameter B is the slope. Since I added a second test serial to the plate layout, it is imperative that I add validation formulas to evaluate TS2. To do this, you can simply highlight the line you wish to copy, hit Control-C on the keypad, scroll to the next empty line and hit Control-V to paste. And I'll do the same for the second formula. So it seems we're having some technical difficulties. I'll just let the software catch up to where I am. So again, what I've done so far is just copied the formulas for TS1, the upper asymptote ratio, and the slope factor ratio. I appreciate your patience. We're at the mercy of technology. Is anybody available to see my current screen? If you are seeing 4 validation formulas, would you mind just indicating that in the chat feature? Okay, so I think we're back up and running. So basically all I did was highlight these 2 formulas and hit Control-C to copy and Control-V to paste them in the following 2 lines. And all I would need to do to change them to TS2 is change TS1 to TS2 in both equations, and we'll be validating both test serials. So please note that anything preceded by an exclamation mark is a runtime prompt. This can be changed to a fixed value if desired, and then turn off the runtime prompt by going to Protocol and choosing Runtime Prompt. So I'll hit OK, and the next data reduction step is the transformation to calculate RP estimate. This is using the Gen5 parallel line analysis metric called REP. Since this is a dilution series, the tech note indicates that RP estimate equals the reciprocal of REP. This is calculated here in well A3. Since we have another test serial, I can copy the equation using Control-C, highlight everything, Control-C, and then choose another well in the TS2 column and paste that along with a change to TS2. The final validation step evaluates the RP estimate for each test serial against a relative potency minimum value. Again, you can just copy, paste, and edit the formula to apply to TS2. Note that our data in is the RP estimate, which was calculated in the preceding step, and that the minimum RP estimate is a runtime prompt variable. The final section of the protocol is for the output. Working with CVB, we have created a predefined text export, which is available in each sample file. In this view, you can edit the export content, as well as define where the text document will be saved. Now you have a customized protocol file that can be used for future experiments to calculate relative potency. From here, we can hit Save and update our protocol. Now I'd like to go over rp_linear_conf.xpt. Because this is a linear file and is using concentration, the main differences between this and the preceding sample file can be found under data reduction. In the first validation step, you will notice that the slope ratio involves parameter A, which happens to be the slope parameter in a linear curve. And in calculating the RP estimate, you will notice in the transformation that since this is a file with concentrations in the x-axis, RP estimate equals Gen5 rep metric. Once you have read a plate, you should get similar results. In this graph view, we show the original reference and test serial curves in a dashed line, along with a fitted curve in a solid line. You will also notice that some results have been masked, as indicated by the white circles. This is something that may have to be done by the end user, as indicated by their particular SOP. To mask a point, simply identify the well ID by hovering over the solid color dot and then going to the Matrix tab to mask that particular well. So we've identified that to be well F3. Asterisks surrounding a well indicate masking, and then you can click on the green check mark to accept the change. Let's go back to the Graph tab, and we'll see that the dot has been changed, has been masked, and is indicated by a white color. Repeat as necessary for a linear curve experiment. Going back to the presentation, here's a recap of our webinar. BioTek has published a tech note and corresponding Gen5 sample files consistent with a CVB SOP for estimating relative potency. These are all available on biotek.com. An overview of the tech note and sample files was given, along with an in-depth explanation of editing a full dose response file and looking at the results for a linear curve file. Questions about the SOP can be directed to the USDA's CVB department. Questions about the tech note and sample files can be directed to BioTek's Technical Assistance Center. Thank you for your attention, and Wendy will be reading some questions from our audience.
Okay, thanks, Elaine. We have one question here that asks, could you show and describe what the final results look like from the export file? Okay. So within the, give me 1 minute, I have to share here, sorry. Okay, within the linear curve fit file that you just saw from Elaine, if you go up here to the Report Export button, you would press that and all the results from this particular plate read would automatically be sent to the text, an export text file. And that could be saved wherever you wanted on your computer. And what the contents of a text file would look like are shown here. So there's this header information with the reading day and time, the version of software you're using, what your experiment file and protocol file names are. If there were any calculation warnings, if one of your validation criteria were invalid, for example, that would be output here. Then there's a procedure summary showing what your wavelength is. The first parameter here to print out is what the calculated RP estimate is, and that comes from the transformation equation that is in the protocol. So in this case, the RP estimate equals 1.214, and that's the number that is validated according to the SOP. Here are the input validation ranges. Again, these are the numbers that an end user puts in at runtime. We talked about the runtime prompts, and there's the exclamation point. The equations for the parallelism validation are then output with a message that they are valid, and if they weren't valid, you would get a message to that extent too. Here is the equation that validates the estimated relative potency value to be greater than or equal to a minimum. That minimum was typed in as 1, as shown up here. And then the specific data from the plate read for each well, including the concentration calculated from the curve, the mean and standard deviation, and CV. This is here for the reference curve here. This is test serial 1. All the test serials you've defined within your file would be printed. And then the curve fitting results here, including the parameter values for your A, B, C, D. There's also an R squared and an F probability value. So that's what's in the export file. And I hope that answered that question. It looks like we have another question here too. Is this final report customizable? Yes, actually it is. Let me show that really quick too. Let me get to the right place here to show that. Here's that linear. So if you go into the report export builder, here's the file here. And here are all the field groups that you can use to customize this report. So over here on the right, these are the groups that are on the file that I just showed you now. There was the data file references, calculation warnings, procedure summaries, calculated RP estimates, etc. So everything that you just saw is already defined. But you can add to this over here. And these parameters here will show you the things that you can add to the report, and you would just insert them. So for example, if you wanted to insert, am I sharing? I'm not sharing? Oh, can you not see this? I'm sorry. Oh dear. Here. Let's see. Gen 5. Okay, here we go. Let me start back really quickly. You would go to Report Export Builder. Here's the report that we just showed on the screen. We would double-click that, and here are the field groups that you can use to customize the report. These are the ones that are already on the report that you just saw here on the right. And then these are additional parameters that can be added to that report here. And you can add and remove these field groups and then go back and look at the export file to see if it's what you want. So you would just keep playing with those until all the information that you want is in the format that meets your criteria. Okay. So let's see if there's another question. Hold on. Is it possible to open previously generated data with a revised protocol?
So I can answer that.
Yeah,
Wendy.
go ahead.
So it is possible to edit portions of the protocol after you've already collected data. The only portion of the protocol that cannot be edited is the procedure. So plate layout, data reduction, and your exports can be edited even after you've collected the data.
So here's another interesting question. Does Gen 5 utilize or allow for a variance function? I'm going to say no, but we can certainly look into that to provide more detail for you if you're interested. But that isn't currently part of the requirements for the CBB SOP. So for purposes of this application, we'll say no. And in general, I would want to find more information out for you for other applications. Let's see. Another question. What versions of Gen 5 will work with these sample files? I'm going to actually have Elaine answer this one too.
So again, these sample files will work with Gen 5 versions 2.01 or higher. I also would like to mention that it will work with any Gen 5 package except for Gen 5 RC or Gen 5 reader control. So standard, secure, IVD should all be compatible with these Gen 5 sample files.
And then another question on the screen, does the FDA provide a similar SOP for estimating relative potency of protein therapeutics for human use? I'm going to have you inquire of that of the FDA. There's a lot of information on the FDA website, and I think that I wouldn't be an expert enough to answer that question for you. So I would inquire directly with the FDA. But that's a good question. And then we have one more question here. Does the tech have to do masking on each plate if it is needed? Yeah, the masking is used for partial linear data analysis. It's the way that we take a linear curve fit and turn it into partial linear data. So yes, it is masked per plate. You don't have to mask, but if you're following the partial linear data approach, you would use masking on the linear approach. Can import data in Gen 5 generated using an older protocol into one of these new sample files? Let's see. Can import data in Gen 5 generated using an older protocol into one of these new sample files, if it's in text format, or you create an import file from it? Mm-hmm.
Yeah, so you can export your older data into like a text format and then change in Gen 5 the type of input you'll be doing. So it can be read from reader, and one of the options is import text file. So you can use that to import it into a newer protocol, a newer experiment. Just keep in mind that it must be the same procedure. So if your wavelength's like 450, or if it's a dual wavelength, just make sure you have both sets of data in that text export. And if you need more details on that, I'm sure our Technical Assistance Center will be happy to assist you with the details on that.
And I see here that this particular question was clarified a little bit. With detail about, for example, cutting and pasting data into the validation spreadsheet.
Yeah, I mean, the validation spreadsheet can always be edited. That's a portion of the protocol that can be edited even after data collection. And then you can delete or introduce new validation formulas as needed, and Gen 5 will automatically refresh the results once you hit OK.
Okay. To those of you, thanks for asking such great questions. I think that's the last of them. I'm going to hand the webinar back over to Lindsay now with some final closing remarks. Thanks.
Great. Thank you very much for joining us today, and thank you to our speakers for their presentations and for taking time to answer some questions. We will email this recorded event to all participants early next week. If you have further questions for our speakers or would like more information on BioTek's products, please visit our website. In addition, please check out our blog, like us on Facebook, and follow us on Twitter to hear more about BioTek webinars or to learn more about our products and how they can help you. Again, thank you for joining us.